Hi, I'm Nils Posegga, and here comes the next video for the new drill down concept in SmartAnalytics, providing hands-on experience for the data drill down. Now I want to start the drill down exercise directly in level 2 using the data selection options there. As in my last video, we are looking at data from our Dallas US campaign conducted beginning of the year. Let's move to SmartAnalytics. I'm in level 2 analysis in my UE drill down workspace. As I'm going to do everything in the level 2 drill down workspace now, I can close down the navigation bar, and I also can increase SmartAnalytics to full screen to save some extra space. So as you know from my last videos, the UE drill down workspace contains of a data selection part and an analysis part. In the data selection part, we first want to reduce our list of sessions and tests to the ones we are interested now in. So I want to do data drill down, and I want to concentrate on tests with degraded downlink performance. And the best test case to do so is the capacity downlink test. So I'm filtering my data set to capacity downlink. I will need to focus on a single operator. I'm selecting AT&T. And I want to focus on the technology LTE 5G&R. This is where LTE acts as a master and 5G in non-standalone mode is added when high data rate is requested. Okay, now I have already reduced my set to the filter defined above. I need to understand what degraded throughput performance means. So I check the physical throughput from AT&T. It's around 55 megabit per second. So tests with degraded downlink throughput performance would be have results well below that. And in my test list, I can see now the average throughput of the capacity test. And for example, I can select here the 11 megabit, which is well below the average 55 megabit per second. In order to start my drill down, I can now double click on this test, and SmartAnalytics will move to the green analysis area. And as in my videos before, the analysis tabs shown are content sensitive to the test I have selected. So I will see service related analysis tabs for capacity downlink, of course some common tabs, and tabs related to my technology, 4G and 5G, as I'm in non-standalone mode. Okay, now I've done my selection, so I will stay a bit on this test, and I can also remove the session and test panel in order to have even more space for analysis for my demo. So in the info tab, there's not much for me to see. I can see that the capacity downlink test was successful. I can see that especially at the beginning, the throughput is quite low considering the technology we have in place, and at the end it seems to be ramping up a bit. But looking closer to it in the further steps. So in my session overview, which will always be present in my analysis space of this workspace, we can see that the data technology is at LTE 5G&R. So we have a 5G carrier, which is then removed, and we have some reconfiguration, and then it's added again later on. This kind of handovers, or like removing and adding of the secondary 5G carrier, can already be an indication for lower throughput. What we can also see, we're doing on the primary cell in LTE, we're doing ping pong handover. So I'm moving from 281 to 159, and then later on from 159 back to 281. So let's keep this in mind, and step by step analyzing the low performing throughput. In the service related tab, we can see further information for the results. So here on the right side we will have the IP throughput, and the bytes transferred, and we can see that there's a slow ramp up at the beginning of the test, which has a test duration of around 7 seconds, and we can see that, like, let's say 2/3 of the test is conducted with very low throughput, like below 5 megabit per second, and then in the end it's ramping up close to 30 megabit per second, which is of course not enough to drive up the overall average, and is also still below the average value of 55 megabit per second we have seen. If we move a bit further down in this service-oriented analysis tab, we can see a breakdown of the throughput in the physical components for the 5G and the 4G leg. And we can see the total physical throughput is the shaded one here. I can always show and remove the different components in this chart, and also the IP throughput I can see here, which should be, from theory, and also we can see this in the practical results, be a bit below the total physical throughput, because it's a couple of layers above, so we remove header information, so therefore we get a bit lower resulting throughput. So let's look at the two components, the LTE throughput, here the dotted line, and the 5GNR throughput. I would like to draw your attention to the 5G throughput here below, which is like not contributing very much, and only increasing a bit. I will just say a bit because we're talking about 5 megabits per second at the end. And the majority of the downlink throughput is coming from the LTE physical throughput, which can be seen here. The total physical throughput is then representing the sum of the 4G and the 5G throughput. Okay, so we have already two indications. We have like ping pong handover in the beginning, plus the adding and removal of the 5G leg, and we can see that the throughput is slowly ramping up, and we got the main contribution from the 4G leg. So let's move on in the analysis and check the 5G radio. So the first two charts are empty. 5G is not configured as the master cell group, but the secondary cell group, so we don't have any information here. This would be filled when we would have a standalone operation, which is not in this case, and we have the secondary cell group here. So if we are looking down at the signal strengths and the signal quality, we can see that the signal strength is moving around -80 to -100 dB, which is not the worst we can imagine. It's also not very good. Well, we can also see two drops here where it really goes further down. And when we're looking at the quality, the SINR marked in red here, we can see really low values below -10, and even some drops where we also can see the drops, and assuming that the synchronization is even lost here in these cases. Okay, this is interesting because we can conclude we have bad radio quality for the 5G leg. Let's look at the LTE part. So what immediately is visible, we have a lot of RC reconfigurations, and they're reflecting, of course, the ping pong handover, the removal and adding of the 5G leg, and of course potentially measurement configurations. So this is the first very visible part. When we're looking at the level of the radio, we can see very low quality at the beginning of the test, and then shortly after handover it recovers, and then at the end of the test the radio quality gets better. Now, remembering that we also had a better throughput performance at the end. So this follows the trend of the quality we see here. Regarding the signal strength, also in LTE, we are around minus 80, minus 70 even. So the radio, the signal strength is definitely not an issue here. But the quality, especially at the beginning, that's concerning a bit. Okay, so much to the primary carrier. Let's have a short glance at the secondary carrier. So here we can see the radio signal strength and quality of the secondary carrier. In light blue we have the SC1, so the first secondary carrier, and what is visible, it's not active all the time. So we're also seeing here that we don't have all the time a contribution from the secondary carrier. Third carrier, or like the legend indicates, a fourth carrier, that's not even visible. So I'm assuming now that we also have a very low contribution of LTE carrier aggregation. Let's confirm this when we're looking at the PDSCH, starting with the 5G PDSCH, but not expecting much here. As we know already, we had bad radio quality, and when we see the PDSCH throughput of the secondary 5G node, we can see very low throughput, high block error rate, and only at the end of the test we're seeing a bit of contribution, which follows what we have seen in the service-related tabs. So tick in a box, 5G contribution really low. Root cause here, radio quality. So let's move to the LTE PDSCH. And this chart draws our attention to what I meant from the LTE radio tab. We have the main contribution from the primary carrier, and the secondary carrier is not contributing much of the time. Let's see how far do we get. Regarding the configuration, we will have several carriers configured with 10 megahertz. This is typical for AT&T. They're deploying the LTE and 5G frequencies in the low and mid bands with 10 megahertz channels. So this is what to expect. And we see here, even though at this point 4 channels are configured, we never get contribution from anything beyond the second carrier. So let's take a look at the contribution of the 2 different carriers. Here below we have broken down the throughput to the 2 different carriers. What is also visible, like in 5G, the high block error rate at the beginning of the test. Just let's move here. This is the beginning of the test, and then here you will have completed the ping pong handover. In this area we really got no contribution, throughput contribution, and then it starts, and the main component here we can see from the primary carrier. The green dots here, this is the block error rate of the secondary carrier, which is also in the beginning very high, corresponding with the low signal quality. So summarizing our findings for this analysis, we would need to classify this test as a RAN issue with the primary cause on bad quality in 4G and 5G. We can also add further information to this analysis, which is low or no contribution from the 5G lag. We have low LTE carrier aggregation utilization, and when the secondary carrier is active, we also have low contribution from this second carrier, again due to bad radio quality. I hope you liked the video, it was useful for you, and stay tuned for upcoming videos on SmartAnalytics hand-on.